Let's do 7 now. Got a unit circle in front of me. So I can see that I've got sine. Oops, gotta see it here. I can see that you got sine, inverse sine, or arc sine of 1. Okay, so this means that you're basically showing me that you know how to read a manual. So this is a good skill. You're basically going the opposite direction from the unit circle. So you want to know where the sine is 1, and I believe he actually already showed it in one of our problems here, where sine of 1 is, we look and see that, okay, where the sine is 1 is at pi over 2. Okay, and in fact that is the only place where he is. And so also to remember, if these guys are going to be functions, we're only going to have one value. I know that tangent can be 1 in other places, but because we're going backwards, we can only be in those specific quadrants. Like here's where cosine is, here's where sine is, here's where tangent is. Okay, so this guy is just not going to be an option when you go backwards from the arc tangents and arc sines and arc cosines. Try to speak up there. Alright, let me see if I can clear this up right here. Alright, so next, we got the arc tangent of 1, so we want to know where that guy is. And tangent is 1 right here. I think we labeled these because we were tired of doing dividing by radical 3 everywhere. So this guy is 1 there, and this is the first quadrant here. Down here he is -1, so we're just going to go with pi over 4. Okay, that's it. You guys did fine on this. Move that over there. You guys did fine with this test, or with the last quiz that we did on this. So those of you that didn't do well, did a retake and you did just fine. So now we got composition. So here are the trickier ones. That's why I put 4 of these rather than the easier ones. So here we're going to go with, we've got the tangent of negative pi over 4. Okay, now the tangent of negative pi over 4. Alright, let's go to negative pi over 4. Negative pi over 4 is right here. Alright, so the tangent of this guy is -1. Okay, now what I want to do then is I'm going to go ahead and take a second here and now have the problem that I did before. Okay, in one step I just made this easier. Okay, so the tangent of negative pi over 4 is -1, so the arc cosine of -1 is actually at, cosine is the x coordinate, and it's right here, so -1, it's at pi. Alright. Okay, so the arc sine of 4 over 5. Now, if you remember, 4 over 5, that's actually one of our special 3, 4, 5 triangles. Okay, this is not to scale. In fact, should be drawn the other way, but that's okay. This is, you need the Pythagorean theorem to do this. Okay. And so 3, 4, 5 triangle is going to give you the other piece that you need. So try to imagine then that what we're doing is we've got an arc sine going into a normal trig function. Sorry, my hands are dry like that. So what I'm going to do is I'm going to use this triangle, and I've got the arc sine would be an angle, right? So the arc sine of this guy would be this angle right here. So now, what we do then is try to think, I don't have to take the time to figure out what that decimal is going to be. Okay, I don't even know what radical is. 4 over 5 is not on my unit circle, so I can't get a clean number. So what I'm going to do is I'm going to have a substitution. Okay, think of it like this. The arc sine of 4 over 5 is that angle, so I'm just going to say it's this guy here is now just going to be theta. Okay. Now what's the cosine of theta? Alright, you've done that 100 times before. Cosine of theta is right here. So it's adjacent over hypotenuse, 3 over 5. Okay? So just think of it like that. This really is kind of a placeholder for you because you are using these values to get to an angle, because it's an arc sine, then the angle is a placeholder for a different trig function. All right. Okay, so now we're going to, excuse me. So now we're going to go and find the coordinate, and then we're going to take that coordinate to get the tangent. Okay? So where is cosine, what is the cosine of pi? So if you look here, cosine of pi, all right, now it's not the arc cosine, so I'm not going from the outside, I'm going from the inside, and that's kind of clear because it's pi, right? It's going to be a radian, so pi is -1, so now I want the tangent, the inverse tangent of -1. All right, what is the inverse tangent of -1? Okay, the inverse tangent of -1, all right, has to be in these two quadrants, all right, in these two. So -1 is going to be right there. So it's 7 pi over 4. But it's, wait a minute, it's not there. Well, if you remember, the way that this works is you have to, tangents, in arctangent's domain is from -pi over 2 to pi over 2. So that means, because of that domain restriction, we have to call 7 pi over 4, we have to call that -pi over 4. Okay, we have to do that, or else it's going to be undefined. Okay. Okay. The secant of 0. Okay, so let's think here. Where is the secant? The secant of 0 degrees. Okay, so we're going to go to 0 degrees. All right, 0 degrees. What is the secant? Well, it's going to be 1 over whatever cosine is. So that's going to be 1 over 1, which is just 1. And so now we want to find out where is cosine 1 as an output, right? We want to think what is the coordinate getting the angle. And we can see here that it's 1, so we're going to have 0. Okay. All right. Okay, 1 and 0, like those guys kind of like, they play with each other, and -1. They kind of play with each other very nicely, so when you take the reciprocal, it's very easy to do. Okay? All right, let's see, we're at the 7-minute mark, so I'm going to go back to 19. All right, even though it's a totally different type of problem. I'm going to try to make this, yeah, okay. Okay, let's do a couple of these before I turn this video off. We've got 3 sine theta plus 2 radical 3 sine squared. Okay, so this guy is squared. I don't have 3 terms. I'm not getting kind of a quadratic, like use the x method here. What I'm feeling is, why don't I take a sine out? I'm gonna do that. Let me take a sine out. I gotta get this coffee. I have 0 coffee this morning, so I'm kind of not as bad as my father. My father is coffee and cigarettes. It's like, it must be the contents of his bloodstream. I don't think he's his coffee and nicotine flowing through there. I'm going to take out a sine. How many sines can I take out here? I can take out, actually, I can take out a maximum of 2. I can factor 2. Let me take, no, can't do that. Take out a 3, then it'll get messy. Let's take out a sine. Okay. Alright, so let's take out a sine. Now notice then what I did is I took out from the 3, I took out the sine. This guy's radical, 2 radical 3, and there's 2 of them, so I took 1 out there. Now that it's factorable now. This is in play instead of having a quadratic. I mean, we do technically have a quadratic, but we're not going to use the x method. So all you got to do is think about, okay, well, what's going to give me 0 here? What will give me 0 here? Just like you would, you know, your typical when we were doing quadratics back in the day. Okay. We solved hundreds of those. So sine is 0 at 3 locations going around the unit circle, right? He is 0 at 0. Okay, so we're just going to list them. Sine is 0 at 0. He is at pi, and do they include 2 pi in our domain here? No, they do not. Okay, so they do not include 2 pi, so we don't have to write it. Okay, so we will just have 0 and pi. Good enough. Now let's go to this guy. Now I know it looks crazy, but this guy is actually not going to be as bad as he looks. If I've got 3 plus 2 radical 3 equaling 0. Okay, now this parenthesis is set to 0. The 3 is going to move over there. Okay, he'll become negative. Then I'm going to divide by 2 radical 3. Okay, and I don't think this is all weird because you have a radical 3. Let's just see what happens. Multiply both the top and the bottom by radical 3. Okay, that becomes 3, so negative 3 radical 3 over 2 times 3. Alright, now the way that these works, if you ever see radical 3 and 2, I mean, don't worry, radical 3 shows up on a unit circle a lot, so he's basically he's going to play pretty friendly. So don't get intimidated by seeing that. We trained ourselves to handle these radicals in the denominator, so 1, 2, those guys cancel, and now you're going back to where is sine negative radical 3 over 2. Now where are those locations? Negative 3 radical 2. Sine is the y-coordinate. So that means that he's going to be in quadrants 3 and 4. Right here I see it at 4 pi over 3. And the other one is at 5 pi over 3. Okay, so it looks like our answers are these two and those two put together. Now what I would normally do is just write them all together with commas separating all 4 of them. However, this will be fine. Now these problems could be multiple choice, so there is a benefit there. All right, we'll do one more, let's see. All right, now I see a cosine there, and I don't like seeing that guy at all. So it's not going to be too big of a problem, I think. Definitely want to set this guy equal to 0. Let's see. Oh, okay, here we go. Got it. Okay, so we're going to go ahead and move this guy over there. Alright, so okay, I see it. Alright, I'm trying to think of the best play here. So I can add those two together. That's negative 3 sine. So I've got neg 2 radical 3 sine theta cosine theta minus 3 sine. Okay. Now you'll notice that I can actually take a sine out of each one of those. So I'm going to do that. So a sine comes out here. Now I know I got the cosine in there, and it feels like 2 sine cosine. We know that that's one of our identities, but it's not going to play well with the way that we want to solve things right now. What we want to do is we want to take a sine out. That's pretty much all that we can do. Now if we do this, then we've got parentheses 2 radical 3 cosine theta minus 3. Alright, now what that does is, yes, I have a sine and a cosine, but they're in separate parentheses, so I'll just treat them as like 2 separate equations. Okay, so we need, if this guy is 0, then we will get 0. If this parenthesis is 0, we will get 0 over there as well. So we've got a sine theta equaling 0, so we already know those from the previous problem. That's 0 and pi. Now let's focus on this guy. He's going to actually be almost identical to this, except he's cosine. So now we got 2 radical 3 cosine theta equaling 3. Now I set it to 0, but I'm trying to speed it up here. Equals 0, so I move the 3 over. He's positive. Now I divide by that right there. Okay, now if you notice, this is basically just the same setup as this. So I know I'm going to get radical 3 over 2. Okay, and he'll just be positive. Okay, now where's cosine radical 3 over 2? He's here at pi over 6. Whoops, pi over 6. And he is also at 11 pi over 6. Okay, so my 4 answers are 1, 2, 3, 4. I'm just going to check the answer key. We are all set. So sometimes though, I guess you could see these in order. So it would be 0, pi over 6, pi, and 11 pi over 6. So they're not going to put them in order of the way that you solve them. They're going to put them in their order around the circle. Okay, so just keep that in mind. All right, and we'll stop right there.